So now we're going to begin the workflow to use the automated image analysis parameters. I'm going to start with a file that has been acquired already. You can see their check marks indicate that there's the FCS file present. And the first thing I need to do is click into it. So you see here, if I have not clicked into it yet, my option to process images isn't available. And so to solve that, I just activate the file, which simply means I'm double clicking it, and that allows me now to right click and process images. This menu appears, which gives me my various image processing options. As you can see here, we have our model, our population, the different parameters that will be calculated, and I have the option to select all samples or just go ahead and pick one or two. If I want, I can choose to only process within a specific gate. It's up to me. However, I prefer to do all events. If I come in here to image processing options, I can change my model, set a different model as default. And when I'm ready to add these to the queue for processing, I just click Add to Queue. If you want to see the queue and where it is in the queue, how long it will take to complete, you just pull that up, and it right here gives us the progress and the estimated time to completion. So most of these are very quick. Something to notice here is that once the image processing is completed, and we'll see that here in just 1 second, we are going to see this check mark change from just a simple check mark to an adorned check mark. That is a check mark with a circle around it. And so now this has been processed. In order to see the extended parameters, you do need to come up here and click Reload the Sample if you happen to be in the sample and have it pulled up when you have it processed. So just click and Reload Sample. And then this will allow you to use all of these extended parameters within the workspace. So if we come here, we can see now we have these 5 different categories of parameters that have been added compared to a sample that has not been processed, which will only have the normal fluorescent and side scatter. So coming back to processing our images, when we come in to select our model, there are 3 to choose from. The beads only model, as it sounds, was trained for beads. So if you are doing anything that is particularly focused on some kind of bead assay or bead counting, this is an excellent model to use. The main ones, though, if you are working with cells, are going to be cell half resolution and cell full resolution. The full resolution model, as it sounds, uses all of the data, and it is slightly more robust. However, it does take a significant amount of comparable processing time, and you'll have to wait longer for processing to complete. The half resolution model is much faster, and it takes requires less processing power, and it accomplishes this by downsampling the image data in a way that's specifically designed to reduce error. So for most samples you'll be working with, the half resolution model is more than adequate. And I have not seen any major differences between the two with the typical immunological models that I work with. The only time I might try to use the full resolution model is if I'm working with cell types that are where the differences between different morphologies, different populations are extremely subtle, such as some populations of red blood cells. That's an instance when I might use the full resolution model instead. So I am going to add some of these to the queue just so that we can see how we might manage the queue. Let me pull this one up. And then because I have already processed these, these are the options that I get. I am just going to say to overwrite and then yes. And I want to do this for all of the samples that I'm adding. So now if we are going to make any changes to the order or the samples that we have added to the queue, you see here I have it pulled up. Oh, yes. And now they're being added. In here, if let's say you added them out of order, you can switch the order in which they're being processed. You can delete them, reset the queue if for whatever reason it does not seem to be processing, pause, and then resume if for whatever reason you need to stop this progress and resume it at a later time. This will process in the background if you minimize this window, and you should not have to worry about needing to re-add any of these to the queue. If you happen to shut your computer down, it will start back up and resume where it left off. So coming back to our original, or to one of our examples, once processing is completed, which we can tell because of the circle around the check mark, we're going to need to do some basic quality control steps of the annotation. So here I'm going to pull up all the images in the sample. And as you can see, this is a bead stimulated sample. This is what I would consider a complex sample type for this model because there are varying morphologies, varying sizes and shapes, varying textures, and lots of dead and dying cells. So if I come over here to my Customize tab, while I'm in the Image View Gallery, this is where all of my image adjustment parameters come up. One of the things that I typically do for scaling is I switch from automatic to manual. And all this does is make the backgrounds all the same tone. This has no impact on the data. This is just simply to make visualizing this just a little bit easier for me. And then if I need to, I can make some little changes here that will then be reflected on in the image window. And if you want to go back, you should be able to reset everything to 0. So now if we are going to show masks, this is the important part for the quality control check. What I am looking for is I am looking for masks, so it'll be this black line, that are significantly incorrect around the cell. So they have annotated a significant amount of the background area. Maybe they have cut through the middle of the cell. Some errors are inevitable. Nothing is perfect. However, you should see a minimal number of errors, a statistically insignificant number. I believe for leukocytes, this was validated no greater than 10% error. So we also want to check the spot count. Again, with leukocytes, this was validated within 10% error for counts on singlets. So if you notice that some of these singlets have been miscounted, that's something to make note of if you are going to use the particle count parameter. For something like this, where we see that there is this lighter blebbing starting to occur, we did not include blebs in part of this model, so these look essentially normal. To me, this looks very, very well annotated considering how messy the sample is. So I have no concerns about these annotations, and if I was going to look and show an example of some well annotated cells, we can come in here and we can see, I turn on these masks. This is a very classic sample with really good masks that are very closely annotated. You see that there's very little complexity in here, and the singlets and doublets appear to be accurate. And so the last thing that we're going to look at is what to do with these parameters and how to potentially export some of these for use in a third-party software. The total number of extended parameters that are exported will depend on the Attune instrument that you're using. This was run on a V6, I believe. So there will be sets of fluorescent parameters for every laser, and one of the first things that we can do if we want to see those is come over here, double click, and I have FCS information. So here are the parameters: event time, forward side scatter, and these will be the extended parameters that would be added. So you can see there's 77 total. Third-party softwares or software that can support this include FCS Express. Some people have luck in R, and it just depends on the software that you're the most comfortable with. There are two options you have for exporting this. The first is to export the FCS files themselves. If you do not want to export the extended FCS format, so you do not want the image parameters added, you simply export like this, make no changes, save it. Oh, hold that wrong. And select. And it will export them pretty quickly. Within the same file, if I wanted to add the extended parameters, and I just, again, want the FCS files, I'm going to come and export the FCS, but this time I'm going to click Extend FCS File. And so I would just save it in this folder and make sure I've clicked the Extend FCS File. And then the final option is you can export the FCS file along with the image data, and this will be exported as an ACS file. Hold on, let me demonstrate that. As an ACS file, as you can see here, and when you export these ACS files, you do have the option to export the extended FCS file with the images. So it's entirely up to you what you plan on doing downstream analysis, and if you want to use these in a third-party image analysis software such as ImageJ. And then finally, what we can pull up here are going to be the image mask files. And so to do that, and this is especially relevant if you are using ImageJ, because that will let you use those image masks in your own calculations. And so let me pull over this example to show you how to get those masks if what you needed to do is import these into ImageJ or similar software for comparison. So public documents, live technologies, Attune CytPix images, and then here in Attune CytPix images, you'll see that there are the mask files. And so the most recent one that I have activated that has been processed should be up here at the top. And so I would just copy this into whatever folder that I intend to work from. And so those are the options and the steps for getting started with the image analysis. And next we'll look at the first steps to take for these using these in workflows in the actual software workspace.